Alright guys, so everything that we have been discussing so far has been taking x only to the power of 1. Right? So if you go back to any of the examples that we have discussed so far, even the ones which were more practical, like easier to visualize, like solve for x, right? You had something like 5x minus 2 is equal to 10, right? So this is fairly simple, and if you look at this, x is to the power 1. We don't usually write it, right? But there is an x there to the power 1. And anytime that our variables, our unknowns, they are all to the power 1, we can say that it's a linear system, right? Or if you've got equations, it's a linear equation. Now, what when they are not linear? So what when this exponent is not 1? That's what we're going to discuss today. So anytime that we have x to the power something, and since I want to make this more general, I'll just call this x to the power of n. And this is equal to k, which is a value, a constant. I can solve this, okay? But we have to look for what is n here, right? So in the cases that we have been dealing so far, it was n to the power 1. So it wouldn't make much sense if I asked to find x is 1. Well, that's already your answer, right? Is if x is 1, then x is 1. The solution for x is 1. So this is n equals 1. What if n is equal to 2? So you would have something like x squared is equal to 1. So in this particular problem, it might look simple again, just like this one before, because you could just argue, well, if x squared is equal to 1, then x is 1. But is that your only solution? What numbers can we multiply to get 1? Well, the easiest that you guys visualize is simply when I multiply 1 by 1 and I get 1. But what if I multiply negative 1 by negative 1? Then I'll also have 1. So do you see that I've got two possible solutions for something squared is equal to 1. Either x equals to 1 will give me 1 squared is equal to 1, or negative 1 squared will also be 1. So I've got two solutions here. I've got solution x equals negative 1 and x equals 1. Let's take a look at a different problem but with the same exponent. So what if my problem now was x to the power 2 is 4? Again, how can I multiply two numbers to get 4? Well, I could multiply 2 by 2, that's 4. But is that my only solution? No. I could also multiply negative 2 by negative 2, and I would also have 4. In fact, if we put enough examples here, you will see that there is a trend, there is a pattern that shows up anytime that we have our exponent equals to 2. So here, when x squared is 4, we had that x was either negative 1 or positive 1. If we multiply negative 2 and negative 2, we get 4. If we multiply 2 and 2, we also get 4. What about 9? Well, x may be negative 3 or x may be 3. That's the same logic. So we can make this a bit more general just by saying that when x squared is equal to k, our solution will be x is plus or minus square root of k. It's as simple as that. And that's exactly what we have been doing so far. You might not have realized it, but that's exactly what we have been doing. Take a look. In this first problem here, x squared is equal to 1. So x is plus or minus square root of 1. How much is square root of 1? 1. So plus or minus 1, which were our solutions. What about the second case? X squared is 4. So x is plus or minus square root of 4, which is plus or minus 2. Exactly what we found before. What about the third one here? X is equal to plus or minus root of 9. And root of 9 is 3. Notice that not always you'll be able to find a nice number. Sometimes you get some surds, and that's how life is. So when x is to the power 1, that's easy, that's a linear equation. When x is to the power 2, we have those equations. What about when x is just to the power of n, as we were thinking about before? Let's see. So in a more general term, if x to the power of n is equal to k, this is a number, okay? So x to the power of n is equal to k. Then you may just find x to be the nth root of k. Now, this works if your number is odd. If your number is even, then we'll have the plus or minus. Now let's see, odd. Well, x squared, our exponent was odd, right? What are the odd numbers? So 2, 4, 6, 8, right? And even 1, 3, 5, 7, and so forth. So even, we could argue x to the power 3, x to the power 5, even x, right? But it doesn't fit here. Now, let's see. So what if I had x to the power 3 is 8? So what three numbers, the question is, what three numbers can I multiply to get 8? That's 2, right? X to the power 3 is 2 times 2 times 2. Now, when we had x squared equals 4, we thought, well, x squared could be 2 times 2, but it could also be negative 2 times negative 2. Right? Both would gives us 4. But what about with the cubic now? Does the same thing work? When this exponent is 3, does the same thing work? It doesn't. Take a look. If I multiply negative 2 by negative 2 by negative 2, I will get negative 8. Because there are two negatives, so I'll cancel those out, but I'll still have one negative. So those are different. So see that now I will have separate solutions. When x to the power 3 is negative 8, x is negative 2. And when x to the power 3 is 8, then x will be 2. Let's see more examples. So what about this one? X to the power 3 is 1. Looks simple, right? And x to the power 3 is 1 times 1 times 1. X is 1. If I apply the rules that we have learned, we would do n equals 3. It's odd. So since it's odd, what are we going to do? Well, x will be simply the cubic root of 1, which is 1. Now let's take a look at some problems with surds. So what if x squared is 6? Now you can pause and try it yourself. Now what you notice here is n equals 2, which is even. So x will be plus or minus nth root of 6. And in this case, n is 2, right? So let's just make this simple. When this is 2, we don't really write it, right? We just write the root. Now this is a surd, so we wouldn't be able to solve it. If you did have a calculator though, you would find this value to be, well, approximate, plus or minus 2.45. So this means that if you multiply 2.45 by 2.45, you should get something closer to 6. However, if you multiply negative 2.45 by negative 2.45, you should also get something close to 6, because those signs will cancel out. Let's see some more examples. So x squared equals 13 and x to the power 3 equals 31. Now you can pause the video and try those yourself, and you can use calculators if you don't have the proper, if it's a surd, and you will be, okay, so use a calculator. Now, if we take a look at this, n equals 2, this exponent is even. So since it's even, x is plus or minus root of 13. Since 13 is a prime number, we wouldn't be able to solve it. So if you use your calculators, you would find this to be approximately 3.61. Now next problem here, x to the power 3. 3 is odd. So it's the same thing, but I won't have plus or minus, right? And the appropriate sign here. So equal to cubic root of 31. Now 31 is also a prime number, so x will be approximately, so if you use a calculator, 3.14. Now, one more problem. Solve for x. Okay, so take a minute to solve this one. So straight away I'm going to tell you the solution should be x equals plus or minus root of 10. Okay, I'll show you how to do it now. So here the easiest way is just to cross multiply. You could also multiply both sides by x. Just remember that when you're getting rid of this x here underneath, you're stating that x is different than 0. Okay, that's a limitation when you get rid of the x in the denominator, because if it's here dividing, it is different than 0, otherwise this wouldn't exist. There's no such thing as dividing by 0, right? So if we cross multiply, we get x squared equals to 10. And now it's easy. That's what we have been doing so far. So x is root of 10, and since this is 2, we will have plus or minus. So root of 10, again, use your calculator. So this will give you that x is approximately 3.16. I'm keeping those values up to 3 significant figures, which is usually how many we keep. But yeah, try to get used of keeping those numbers of significant figures if you're not asked for anything different than that. And that's all we have to discuss regarding this. And next we'll go into inequalities, using them in linear systems and solving equations with linear inequalities. And after that, it's geometry, lines, angles, polygons. Have a great day, everyone.